So we're going to look at logistic regression, and we're going to really try to understand logistic regression is really good. So some advantages of logistic regression: you can explain what's happening. Why is it important that you be able to explain what's happening with your model? So that we are going to build models that we don't really understand and that we don't really know, but we'll still use them. But there are situations where it's really important. And a third thing is it gives a probability rather than a direct prediction, which is nice because that allows you to set the threshold of what the prediction should be. So for instance, what if you were building a model and you want to predict whether or not someone should go get a cancer screening? You may want to set the threshold for that very low. If there's even a 20% chance they have cancer, you want to encourage them to go get a cancer screen. And it may be that you don't want the model to actually tell you, no, they shouldn't, yes, they should. You want a probability that you can tune based on how sensitive it is. Now, the disadvantage, nothing fixes it if your data isn't linearly separable, unless you do some really hard work. So it's not very adaptable. It's built for what it's built for. It's not like a neural network. Oh, it doesn't do well if it gets something totally unexpected. So some models, they know what they're supposed to see, and when they see something that's really weird, they can tell you that more or less. Linear logistic regression is not going to do that. If it's getting something really weird, it's still going to try to force it into the framework it knows. So it doesn't work with. And one thing that logistic regression is used for is you want a baseline model often. So even if your plan is to build some really complicated model, you want to build a simple model first just to see how it does. I can't remember. So logistic regression, as you see in the linear model library, it's not in the classifier library, it's in the linear model library. So I'm going to do from sklearn.linear model import. I have the ability to make a logistic regression object. Before I do that, you want to split your data into a training set and a testing set. So if you use 100% of your data to train the model, how do you know that you actually have a good model? It's from sklearn model selection, and it has underscores. So from sklearn model selection, import train test split. So it's X train, X test, Y train, Y test. So I'm going to be creating 4 different things here. I'm going to be creating a training set and testing set for my X, and a training set and a testing set for my Y. It's train, test, split, XDF, YDF. How do I specify the percentage? Is test size. I'm going to specify test size as 30%. So now this created 4 different things, and we can look at them real quick, one by one. If you remember, we had 50 samples. So we would be expecting X-train to have how many samples? 35. And we have 50 total, and we're taking 70%. And the way I do that, I first create the model. So I'm going to create a model, and I get to call it whatever I want. What do you want to call this logistic regression model? Okay, so Bob equal to logistic regression. And I'm going to call it with no arguments. I'm going to let the computer just decide whatever the default arguments are is fine with me. So now Bob is a logistic regression object. I'm going to feed Bob the training data, teach him the training data, the example from X-train, and then telling him what the correct label should be. And the way that I do that is I'm going to call bob.fit X-train, Y-train. Oh, this always happens. It does not like the fact Y-train has 1 column. I'm going to import numpy as NP, and at this point, I might as well just restart the kernel and run all cells to get everything going again. It still doesn't like that because it's telling me, oh, it's a data frame. Okay, let me think about this for a second. Looks like if I call .values.flatten, that works. So that looks good. So let's just make that be the new thing. Okay, so now what is the type of Y-train? Beautiful, it's expecting an array and it wants an array, so now I can do bob.fit X-train, Y-train, and okay, so Bob has been fitted. So now Bob knows what to do, can be used to predict. And what we can do is we can get a sense of how well Bob is working by calling Bob.score X test Y test. And it got 100% accuracy, friend. Let's declare victory and go home. Case because the data set was so simple. So the big things I want you to retain out of this is that you can create a model, and you can fit the model, and you can score the model in 5 lines. And that's something that if you only have 30 minutes to build a model, you can just jump in and you can start building models and you can come up with something.